moving on from models to controllers. And there's a couple of neat concepts in here that are going to take a couple of times through for you guys to see them. So we'll try to see them over and over again. Controllers, routes, and REST. And here's where we are, right? Always trying to maintain our orientation. Controllers. And controllers are, for the most part, limited to the app server, right? Controllers don't have to manipulate persistent data. That's pretty much the model's job. So let's take a look. So let's talk about routes first. This is a simple concept, but it's an important one. Because in a model view controller app on the web, since each interaction the user can do has to be handled by some controller action, we need a way to figure out an incoming URI, what controller action is going to take care of that. Right? Now, in the Rails world, a controller action is just a method in a file somewhere. So really, this is a way of saying, given a URI is coming in from somebody's browser, how do we figure out what file and what method is going to ultimately handle whatever the user wanted to do? So a route is just a way of mapping an HTTP method, like get or post. We talked about these when we did our HTTP overview, and a URI to some controller action. Okay? Fundamentally, that's all it is. So here are some examples of possible routes. If we have a route where the HTTP method is get, and the URI is /movies/3, this could be a way to say, show me information about the movie whose ID in the database equals 3. A route with post/movies could mean create a new movie from the information that's in the form that's attached to this HTTP request. And you guys will do a little bit of that in homework number 2. We could say put /movies/5. That might mean here's an attached form with some new data to update the existing values of movie whose ID is 5. Or delete /movies/5. Get rid of that one completely. Notice that in our example route for posting and to create a new movie, there's no number that maps to any ID because we're creating a new movie, right? It doesn't have an ID yet. Presumably, it'll get assigned one once it gets created. So these are some examples of what routes might look like. Those of you who have done some web programming before might say, wait a minute, I know about get and post. What's put and delete? Put and delete actually are part of HTTP. They're not generally implemented by any widely used web browser, but because the sort of recommended way to deal with certain actions like updating is by using put and delete, there's actually special machinery in Rails that allows you to pretend that your form actions are triggered with put or delete, and Rails will do the right thing to make it look that way to the controller. So this is described in more detail in the book. You don't have to worry about it too much except to say, true, web browsers can't really do put, but Rails can fake it so that it looks like that's what they did. OK, so a brief introduction to the part of Rails that deals with routes so that you know what you're getting into. The routing subsystem actually does a couple of different things for you. One of them is what we just saw. It takes a method and a URI that's incoming, and it matches it or dispatches it to the correct controller action. But it also does a few other things, right? Because when you're generating views, you also may need to go the other way. For example, if you want to generate a form which, when the user fills it out, is going to cause some existing movie to be updated, one of the things that form is going to have to contain is a URI that will take you into the correct update action with the correct movie ID. So rather than you having to construct all that by hand, the routing subsystem also gives you some shortcuts to help you do that. Another thing that it does is when we looked at URIs, sometimes the URI has parameters attached to the end, like query parameters. Other times the URI is accompanied by a form posting with a bunch of stuff that the user filled out on a form. In either case, the routing subsystem will take that stuff and put it into a convenient hash that you can just manipulate inside the controller. So it does that for you. And there's built-in shortcuts provided by the routing subsystem to generate CRUD routes. Why for CRUD routes? Because CRUD routes are sort of fundamental, right? Any application that manipulates persistent models at some point is going to have to be able to do CRUD on every model. So it makes sense to have a shortcut that with one line of code, you get routes for all of the CRUDs. So what would be an example of this? Suppose the web browser is, we get a request that says get /movies/3/edit. So what's going to happen, assuming the routes are as displayed down here? And by the way, if you were doing the background reading in the book, there's a command that you can type in any Rails app that's called rake routes, and it will show you what all of the routes that are set up for that application are. So this is an example from the Rotten Potatoes app that's developed in the book. What happens when this URI arrives? Well, first of all, which route is it going to match? Because we have to match both the HTTP method and the URI. Well, here's a match, right? Because in a route, these parameters with a colon are like wildcards. So that means that the route that's going to match is down here. That means that it's going to call the edit action in the movie's controller. And when that action is finally called, and that's part of the code that you would write, this params hash is already going to have ID set up as 3 because that was matched against the ID token in the URI. The controller action will do all of its stuff. And now, suppose one of the things the controller action is going to do, and in fact, there's an example in the book that walks through, and a screencast as well, in fact, that walks through how you update an existing movie. The first thing you do is ask to edit it. That gives you back a form with the existing information. You make your changes. And then when you submit the form, there's now a different controller method that's going to take your stuff that you typed and apply it to the data. So somewhere in the form that gets served by the edit method, there has to be a URI that will take us back into the update method. And this is where the second part of the routing subsystem comes in. You could try to construct that URI manually, or you could just say update movie path. Now, why does this work, right? Remember in the last, when we talked about the Ruby metaprogramming, we said one of the things that is a very common Ruby idiom is to take a look at the names of classes or the names of objects and create new methods for the convenience of the programmer based on those names. So why is it update movie path? Well, it's update because that's the CRUD action that we want to have triggered. It's movie because that's the kind of item we're manipulating. If we had a moviegoer class, then there would also be a method update moviegoer path that we could use. If we had reviews, there'd be an update review path that we could use. And in fact, there's not only update, there's shortcuts like this for all of the CRUDs. So there's a create movie path, there's an update movie path, there's a delete movie path, and each one of those will expand to both the correct HTTP method and the correct URI. Right? So it's a nice closed loop. If you decide for whatever reason that you want to change the way that the routes map URIs to controller actions, you can do that. And as long as you haven't hard-coded URIs, as long as you're using these helper methods, everything will still work. So this is a nice bit of dryness. And you'll see this in homework too. OK, so this brings us to kind of what the big idea is behind routes, especially as implemented in Rails, and especially as implemented in the last 2 or 3 years when this idea really caught on. This is an idea called representational state transfer, or just REST. And if you hear people talk about RESTful services, RESTful URIs, this is what that idea means. It means that when you do a request to a service, the request is self-contained in that all the information needed to figure out what to do is contained in that request. It doesn't depend on what happened before. You could try to learn about this by reading Roy Fielding's PhD thesis. I don't recommend that. I recommend you instead read this slide, the Wikipedia article, and what I think is an incredibly great description in the book, despite the fact that I wrote it. OK, but if you look at the Wikipedia article, one of the points it makes is REST is not that complicated. It's just a description of the features that made successful web services be successful. Right? So what would be an example of a RESTful service? There's an example that we kind of walk through in the book saying, if every URI is the same, but the page views that you're seeing are different, you should be suspicious, right? That means that, in some sense, what the web service is doing must depend on what came before. On the other hand, if every URI could sort of stand alone, and without seeing what came before, you could figure out what it was trying to get the service to do, probably it's more likely that that's a RESTful service. And if you have a RESTful service, you can create URIs that are equally RESTful to name those operations. Now, I struggled a little to think about what could I show as an example in lecture that would go beyond what was in the book. And it occurred to me that it might be better to show an anti-example. So let's show a non-RESTful service example. And again, this is real live code that works and does something. So don't worry if it looks, don't worry if you can't parse every line. I hope I didn't put my actual password in here. Good, I didn't. Let me make this a little bit larger. OK, so what's the background of this? As you know, as faculty members, we are obsessed with filthy lucre. And we want to know how many copies of our Kindle book have been sold. There's a website that Amazon provides for this purpose, but you have to go to Amazon's page, then they redirect you to a different login page, then you have to go to click on something that says My Bookshelf, and then there's some JavaScript weirdness that as you click different report types, it overwrites different areas of the screen. It's highly non-RESTful. So what does that mean? We saw a similar example of this before. Here's my friend Mechanize, which I'm going to use to scrape the website. I have to get, by the way, this is one line of like a 5-line URI. It's super, super ugly, so I just cut out the rest of it for clarity. And not only do I have to get that form, then I have to go get another form that relies on the fact that I first got the first one or else it doesn't work. Then I have to, actually with my real email and Amazon password, I have to set up all of these form variables. And by the way, you may ask, how do I know how to do this? Trial and error. I did it by hand, and at each step I used the web developer tools from Firefox to look at the source, see what Firefox was sending, and kind of cut and paste all that stuff into my code. Right. And by the way, the moral of the story is, if you can script it, or if a human being can do it at a web browser, it can be scripted, unless it's like identifying CAPTCHAs or something. OK, so I set up all these stupid variables. Then I do another post. Then I have to do a get. Then I have to do some other garbage that involves parsing some JSON. And finally, I have to dereference this ridiculous-looking JSON hash to find the one number I frickin' care about, which is how many copies of the book were sold. OK, what's the moral of the story here? There's 1, 2, 3, 4, 5, 6 separate operations between the client and the web server going on in this example. As far as I can tell, after hours of investigation, this is the only way to get one piece of data. Wouldn't it be nice if there was a URI that just said, get book sales for whatever title or whatever ID the book was? That would be RESTful. This is not RESTful. To get the one piece of information that I know is in a table somewhere, I have to go through this sequence of essentially arbitrary things, which are stateful, by the way. The reason that these URIs are all constants is that Mechanize automatically saves the cookie that comes back from the server and makes sure to include it every time I do something new. The server is using the cookie to track each of the steps. So if you leave out any of the steps, it doesn't work anymore. Believe me, I've tried. OK, so that's my illustration. Why should you care about REST? Because if you want your service to be part of a service-oriented architecture, you want to make it easier for other services to selectively do different operations that your service provides. This is not the easy way to do it. Right? The easy way to do it is stuff like this. Right? URIs are simple, and you can just look at the URI and see, I know what operation is being asked for, and if there's one or more entities involved in that operation, I could figure out what they are just by looking at the URI. In a nutshell, that's what REST is. As with so many other things, Ruby or Rails doesn't prevent you from creating a non-RESTful application, but it gives you a lot of help to make it RESTful. So it kind of makes it easier to do the right thing than to do the wrong thing. And you'll see a little of this in homework, too, but as you start to develop your own projects, it's something that you'll want to keep in mind. By the way, I've shown just some examples of routes that correspond to the basic CRUD actions. Obviously, any non-trivial application is going to do more than just CRUD on a simple action, right? For example, I might say, show me the movie that has the highest rating from among all of my friends. That's still a RESTful action, right? You can express that concept in a URI. It just isn't one of the 4 simple CRUD operations. And yes, Rails does provide ways for you to establish RESTful actions with RESTful URIs beyond the simple CRUD stuff. I just used CRUD because it was an easy example to get the idea across.